Hi, in this second video on simultaneous equations we're going to look at an alternative way of doing it from the elimination method. This is called substitution, and it enables us to solve simultaneous equations where we've got one that's a straight line and the other one that's either a straight line, a quadratic or a circle. So it gives us a little bit more flexibility. This is a higher GCSE topic. You're not going to see any of these on foundation, and in fact we're going to use these skills all the way through A level as well, so it's a really good one to be able to get under your belt if you're going to go on and study further. Okay, let's have a look at what we're going to do. So throughout the video we're going to look at various things. We're going to look at solving simultaneous equations by substitution, and like I said at the beginning, we're going to do one example where we've got two straight lines. We're going to do one where we've got a linear and a quadratic, and we're going to do a linear and an equation of a circle as well, so you can see what those ones look like. I'm also going to get you to do one at the end as well. Okay, so let's make a start on this one. This one says solve simultaneously, and we've got these two equations here. Now, it looks a little bit different to normal, because normally when you've seen them in the past we've got an x and a y and it equals a number. Here I've got a y equals. Now I'm sure your algebra skills are good enough that you could actually rearrange this first. So you've got an x and a y and a number, and just use the elimination method. And that's fine, you'll get the same answer, but what I'm going to do is show you how you can do it a slightly different way. What I want you to notice is that we've got x plus 3y here equals 8. We've also been told that y equals 5x minus 16. Now, if that's the case, then what we can do is substitute everywhere we see a y. So we had x plus 3y equals 8. Everywhere I see a y, I'm going to swap it for 5x minus 16. So this y here, I'm going to make 5x minus 16, and it equals 8. Hopefully what you can see here is that we've got rid of one of our variables. We've actually got rid of the y. In this equation we've now got just x's, and the whole point of when we're trying to solve simultaneous equations is that we're trying to eliminate one of the variables, and actually we've done it here, but instead of taking one equation away from the other, we've just substituted it in. Now we haven't quite finished. What we need to do is actually solve it for x. So we've got x plus, and then we can expand this bracket out, 15x minus 48 equals 8. Collect all my like terms, so 16x equals, and I'm just adding 48 and 8 together now, so that gives me 56. And x is going to be 56 divided by 16, which gives me 3.5. Now once I've got my first value, once I've got a value for x, I can substitute that back into either of my equations to work out what my second value is. I'm going to do it in the first one, I think. So I've got, instead of x plus 3y equals 8, I've now got 3.5 plus 3y equals 8. Take 3.5 away from both sides, so 3y equals 4.5, so y equals 1.5. Okay, so I've got x is 3.5, y is 1.5, and these are my solutions here. Sometimes you might find that it's quicker to do it this way, and it might be a method that you prefer to do. It doesn't really make any difference at all whether you want to rearrange this type and do it using elimination, or if you want to use this substitution method. There are real advantages though. On the next couple of examples we're going to say it really is the only way that you can have a go at doing it. Okay, so here we go. This one says solve algebraically these simultaneous equations. Now we've got here something that's got an x squared in it. So straight away we're thinking we're going to have some sort of curved line, and we've got a straight line. Now if we've got a curved line and a straight line, what I want you to kind of appreciate is that you could have the situation where you've got something like this, and we're going to have the possibility that we've got two different places where these two graphs meet. Remember that simultaneous equations is what we're trying to do, is find out where the equations of these two lines cross. So it could be that we end up with this sort of situation here. I'll show you how you do it again in exactly the same way as before. It tells us what y is. So here we've got y is 5 minus x squared. Our second equation says x plus y is 3. If I take my second equation, x plus y is 3. What I'm going to do is every time I see a y, I'm going to erase it, and I'm going to swap it for 5 minus x squared. Like this. Okay. So 5 minus x squared. Write that out a little bit neater. X plus 5 minus x squared equals 3. Now, that doesn't look like it's in a particularly nice format, but what we can do is rearrange it and make it look like a nice quadratic that we can have a go at solving. And remember we solve quadratics by factorising them, so that we want to get it into a form where we can factorise it. Let's have a look then. So we've got minus x squared plus x. If I take 3 from both sides, I've now got plus 2, and that equals 0. Now, if you like, and I do, I would prefer if all this was positive. So what I'm going to do is multiply all this through by minus 1, and that gives me x squared minus x minus 2 equals 0. Okay, so I've just switched all the signs. So in effect, I've multiplied every term by minus 1. I'm just going to find it easier to factorise at this point. So remember, factorising, we're finding numbers that multiply together to give us minus 2 and add together to give us minus 1. So we're going to have, definitely going to have a 2, we're definitely going to have a 1. I'm going to have to have minus 2 and positive 1 here. So my solutions are going to be x equals 2, and another solution, x equals minus 1. Now, when we've got these two solutions, we're going to have to substitute each value for x back into an equation to get its corresponding y value. What that's doing is finding the coordinates. You're going to have a pair, an xy coordinate here and an xy coordinate here. Now, I'm not saying that these two graphs are exactly the ones that we're looking at, but you can see why we've got two x values now. We've got an x value from here and an x value from here, and what we need to do now is find its corresponding y value. So when x equals 2, x plus y equals 3, so 2 plus y equals 3, y equals 1. So we've got one solution, x equals 2, y equals 1, and we can do the same when x equals minus 1. Then I've got minus 1 plus y equals 3, so y equals 4. And again, I've now got x equals minus 1, y equals 4. And if you prefer, you could write those as coordinates. You could have 2, 1, and minus 1, 4. They're the 2 points where these two lines cross. Third example then, we're going to have an equation of a circle. I'm hoping that you've spotted this one here. So we've got x squared plus y squared equals 36. At GCSE you'd be expected to know what that looks like. If you've had a little think about it at that point, I'm hoping that you've decided that it's going to be a circle centre at the origin with a radius of 6. And we've got a straight line here, y equals 4 minus 3x. So that's going to be a line, and if we want to have a little go at sketching it, that's going to be a line coming down this way, quite steep in the negative direction, minus 3 gradient, and it's going to cross the y-axis at 4. Okay, why don't we have a go at just very quickly sketching that out so we can see. So here is my circle. Okay, let's say that this is 6 up here and minus 6 down here, and 6 and minus 6, and my equation of a line is going to cross through 4, and it's going to be quite steep. So it's going to be something like this. So you can see we're going to get two solutions. We're going to get one up here and one down here. That's how we go doing it. We're going to do it in exactly the same way. We're going to use the substitution method. So I've got x squared plus y squared equals 36. But I've been told what y is. So because I know what y is, I can change this y here for 4 minus 3x. So I've got x squared plus, and I always put these things in brackets to keep it tidy, 4 minus 3x squared equals 36. Remember, it was y squared before. I've been told what y is this, so it's all that squared. Okay, so now I can multiply out my brackets, collect my like terms together, tidy it up, factorise it. So I've got quite a lot of work to do. So we've got x squared. If I expand this bracket out, remember that this would be 4 minus 3x multiplied by 4 minus 3x. So that's going to give me, first pair 16, I'm going to have minus 12x minus another 12x plus 9x squared. So that's going to be plus, and again I'm going to keep this in brackets just for the time being, 16 minus 24x plus 9x squared equals 36. Right, collect all my like terms together then. The reason I put them in brackets again, if this was a minus sign, it affects the things in the brackets. It turns out to be plus, so we don't need to worry about it too much. So what we've got is x squared plus 16 minus 24x plus 9x squared equals 36. Right, now I'm going to collect all my like terms. I've got 10x squared minus 24x. Take 36 from both sides, minus 20 equals 0. So I've now got it in the form of a quadratic that I can have a go at factorising. Now the question, I didn't actually write it on here, but the question did say leave your answer to a couple of decimal places. So what we can do is we can use the quadratic formula. Remember the quadratic formula given in the exam, it says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to substitute all my numbers in. You can do this, you can take your time over doing it. B is minus 24, so we're going to have x equals 24 plus or minus the square root of, and we can put all our numbers in. So we've got minus 24 squared minus 4 times 10 times minus 20, all divided by 20. I'm going to put these numbers in my calculator. I'm going to do the one with the positive first, so I'm going to have the positive value first. That's 24 plus all this, and I'm going to get x equals 3.05. On my calculator, for when it's the negative value, so 24 minus all of the stuff we've got over here, then I'm going to get x equals minus 0.65. Again, I've just rounded this to two decimal places. I've got two values now. I've got my two x values. I've got a value here for x, 3 and a bit, and I've got a value here, minus 0.65. Okay, and that kind of looks about right for what we're doing here. What we need to do now is substitute back in and find our corresponding y values. So when x is 3.05, we can say that y equals 4 minus 3 lots of this, 3.05, and that's going to mean that y is, and again I can do that on my calculator, so 4 minus 3 times 3.05 is going to give me minus 5.15, and the second one, y equals 4 minus 3 lots of minus 0.65. That means that y is going to be, again to do that on a calculator, 0.65 equals, and we get 5.95. So the two different places where these cross, I think, are going to be there and there. So the coordinates would be 3.05 minus 5.15 and minus 0.65, 5.95. Okay, and again, just having a quick look on the sketch that we did, that kind of makes sense. We're getting sensible sorts of answers. These values we'd expect not to be as big as 6, because 6 is on the circle right at the very, very edge. These are a bit further round. That kind of makes sense. The sketch that we've drawn shows we've got a positive x value and a negative x value. That makes sense as well. There are lots of marks for these questions, so yes, it takes a long time. There's a lot of working to be done and using a lot of your math skills all the way through. Feel confident enough at this point, have a go at this one, and again, give your answer correct to 2 decimal places. I'm going to pause the video and I'll show you what the solutions are in a second. Okay, what I'm going to do, I'm just going to draw a quick sketch of what this looks like. Again, this is for my own benefit and yours as well. So we've got a circle. The first equation is a circle. Here it ends in 4, so it's going to have a radius of 2. So 2, 2, minus 2 and minus 2. And we've got y equals 2x plus 1. That's going to be a line that's going to go something like this. So we've got 2 solutions that we're looking for, one here and one here. Okay, now if we start to go through this, I'm going to substitute them in. We've got x squared plus, now y we know, so we've got 2x plus 1 squared, this equals 4. X squared plus, and now I can expand this bracket out, I'm going to end up with 4x squared plus 4x plus 1 equals 4. Collect all my like terms together, 5x squared plus 4x. Take 4 away from both sides, so minus 3 equals 0. And then we're going to use our quadratic formula. So minus b, I'll write it again up here, minus b plus and minus the square root of b squared minus 4ac all over 2a. And we know what our a, here's our a, here's b, here's c. Punch all the numbers in. So we've got minus 4 plus and minus the square root of 16 minus 4 times 5 times minus 3, all divided by 10. Okay, so we've got minus 4 plus and minus, and then here we've got 16 minus, plus 1260. So we've got 66 here, 76. 76 root 76 over 10. So the 2 solutions that you're going to get are when we've got minus 4 plus root 76 over 10, and when we've got minus 4 minus root 76 over 10. Just check that you've got these solutions somewhere, and you should get 0.47 and minus 1.27. So these are your 2 x values. Substitute them back in and you'll get the corresponding y values to be at, let's see, so we're doubling that and adding 1, so we've got 1.94, and the second one again doubling it and adding on 1 minus 1.54. So these are the 2 solutions that you should have got. Again, I've taken this from an actual exam paper. There's 6 marks for doing this, so don't be surprised with the amount of time that it takes you, the amount of work. But if you don't get all the way to the end, don't worry. There's lots of marks to be picked up all the way through. For example, even substituting in here, collecting your like terms together and getting it into some sort of quadratic here. If you can have a go at factorising your quadratic or having a go at solving your quadratic, you're going to pick up marks before you get your accuracy marks for your final solutions. When we've been doing these revision videos, then there are notes to be taken. The substitution method, in terms of things to look out for, look for a y equals or an x equals. If both equations are y equals 3x plus 1 and y equals, I don't know, 2x minus 2, then if y equals this and y equals this, then they must equal each other. 3x plus 1 equals 2x minus 2. Again, I've got something that's just in terms of x's I can rearrange and solve, and then substitute it back in to find y later. You're going to end up being able to do these sorts of things quite well once you've got comfortable with all of your algebra and you've done enough of these kind of to practice. So make sure that you are good at collecting like terms and solving equations. Make sure you can factorize and use the quadratic formula, and also make sure that you are fairly comfortable with what the equations of a quadratic and a circle look like. Okay, this is a really hard topic, definitely an A-star, very similar to the stuff that you will go on and do at A-level. If you're able to do these, well done, big pat on the back. As ever, good luck in the exams. If you need any information, you can of course always contact us at Tupton Maths or at Mr_G_Walton. Thank you, bye bye.